Hello everyone, this is the Hydra Book Reading Club episode 13, and just like in the last video, I'm going to continue on the topic of motions or movement or how to make things animate on the screen. And in the last video, we explored how to make some kind of transitions using layer and masking, just like how you would do it with blend function and arrow function in JavaScript, but in a different approach using OSC. And this video, I will do something very similar idea. That is, I'm going to use OSC as so-called low frequency oscillator or LFO, and I'm going to use other function, which is modulate, rotate, instead of blending or actually layer and mask. But let's see how it's gonna go. And first I'm gonna make myself small. And if you haven't watched the last video, I highly recommend to go through that. And also, as like housekeeping, if you are familiar with Hydra, that's great. Let's have fun coding. And if you are not familiar with Hydra, or if you're not sure about some functions, you can also go back to the Hydra beginner's tutorial and intermediate tutorial that I've made in the past, and that will explain all the details, all the tools you need to follow the videos on Hydra Book Reading Club, because it's a little bit more advanced than the previous ones, or more like focused, I would say. All right, so what we did last time is basically I was like using something like this, OSC1, one.out, which is like quite boring compared to normal OSC, that you don't see like these like kind of texture on the screen, but this one is more like a counterpart of like LFO on like sound programming, for example. You would have like really like low frequency changing, it can be sine wave or sol wave or square wave, whatever. And I would say like something is like just like that. It's going to be like more like a control signal rather than like making the texture by itself. And last time we did something like, I'll just improvise. It's going to be a bit different intentionally also. And let's say I have this pattern, I have Voronoi as well, and I want to have some kind of transition between them using this OSC. So for example, I can do, well, the classic way of doing it is with blending, and put it here. Let's say arrow function math.sine time, and just to be precise, I want to kind of normalize this value like this. So it goes back and forth between two textures. This is one way of making, well, like some kind of animation, or it's not really a movement or motion, but let's say animation, dynamic, like temporal animation, whatever. Well, animation is temporal, I would say. But another thing that I introduced here in the video is that instead of using this arrow function notation, and it's more like a, I always call it a P5JS kind of style, instead of that, I can do mask and use this famous OSC as a mask, so that this makes like transition very similar way. Now it's like not uniform, it's kind of like also spatially like not all the pixels transition at the same time. If you want to make it a bit more crisp, you can do like thresh. And also if this thresh is too harsh, like you see this wipe, this is also interesting. And if you don't like the wipe, you can also tweak the second parameter to make it a bit softened, or maybe 0.2, depending on what you want. And we also explore the Kaleido to make it like wipe from the center into the center if you reverse the speed of OSC. Also, I didn't do it, but you can also do like pixelate, I don't know, like 8 or something, so that it makes this kind of pixelated transition effect. All these things are possible. Now, so what I'm going to do now is, so this is the recap of the last video, and in this video, I'm going to use modulate, but in a very similar way. Now, I'll stick to this shape because shape is easy to work with. Something like this. And I want to move this shape. Maybe I'll make it a little bit smaller. 0.3 is a default parameter, so maybe 0.2. And for example, if you have like scroll function, maybe the scroll x, and very similar way that just I did with the first example of like blending, something like this. Maybe this is, oops, okay, I didn't do time. Okay, so this will make this shape to go scroll x, so scroll in x direction, going back and forth. Maybe the effect is too like drastic, so maybe I'll just like make it 0.2 or something. So this goes like oscillate back and forth. Again, it's very much like P5.js type of idea. In P5.js, you would use, I guess, translate function to position the object and draw it there. So it's a very similar way of thinking that I can scroll X. Maybe the order of things are different. In P5.js, you would translate and draw a shape. Well, there's no shape function, I would say, but you can do like begin shape or whatever. But that's not really the point. In Hydra, what we're doing here is Hydra, and I thought like if you are familiar with P5.js, that might help a little bit of understanding what's happening. In Hydra, you start with the shape and say, okay, I'm going to scroll it. That comes after, and you can define whatever function you like. This doesn't have to be sine function. This can be cosine or tangent. Probably doesn't really make sense so much, but you can like put things like in a JavaScript way, not really Hydra way, what is happening inside where I'm highlighting right now. But also we can do something really in a very Hydra way, which is not to use these functions, but just use functions like OSC. Because here you cannot use OSC because this is OSC is a texture, it's not a value. And this is like a value that is like the numeric value that is outputting. So maths.sign, whatever you input, it will return something from -1 to 1. It's a numeric value at that given time, or the parameter here. But OSC is a texture. It is, well, it's kind of a shader actually what it's generating. So it's like very different idea from like single value. It's more like an array or a grid of values, but in a very like shader way. I don't know how to say, but it's okay. So what I'm going to do here is, instead of using scroll X, what if you do modulate? And I'll do something like this, just to have this counterpart here, and let's see what's going to happen. And interestingly, this already does something very similar to what I just saw with this example. I'll just like copy it here so we can, oops, have this kind of back and forth we can do. And maybe like what I could do is to really like simulate this exact JavaScript way of writing in Hydra way of writing. Is that exciting? Well, I'm not sure if that's exciting to you, but it's exciting to me. So that's why I'm making these videos. And also it will become something very interesting towards the end, so like bear with me. And what's different here between these two examples is that here it's like going diagonally, and this is easy to fix. Actually, what we need is the color function, because when we work with modulate, what matter is the color red and green of OSC, and red corresponds to the X direction, green corresponds to the Y direction. And this I explained already in the modulate chapter of Hydra Book Reading Club, so if you haven't watched it, that's where you can learn a little bit more about what is happening inside. And exactly like I did recreate this with P5.js. Now, so another difference here is that the magnitude is different, but also like in the second example, it goes like from left to right, but this only goes from left to the center. So how to fix this, it's also quite easy. We just have to do brightness. Now, the reason why this is happening is math.sign returns from -1 to 1. So it kind of like goes like past 0. But OSC is the color that returns is from 0 to 1. So it doesn't go past 0, like to the negative direction. So I always like pair it with brightness. It's a little bit long function, but lengthy. But then if you add this, then it will go all the way to the side. Well, it's not enough. That's also easy to fix because we can always use the second parameter of modulate. I know it's getting a bit longer, so you don't see that it's actually a second value, but it's like this. The anatomy of modulate is that we have this texture here and a number, which by default it's 0.1, but if you make it 0.2, then it will go a little bit further. And always like when I talk about feedback, for example, I try to keep it like small, very small, starting very small number. But sometimes in this case, for example, you can go quite wild, like 0.5 is also like, it's okay. It's modulate with 0.5 sounds like really like something bold. But in this case, it's like totally fine. So I would do that too. But let's keep it like at 0.3, which is very similar to this, maybe 0.4. It may be that I need to like double it. And also you start to notice that in this modulate example, the one above here, it's actually like stretching a little bit the triangle, which is like, it's kind of funny. And we want to probably come back to this afterwards, but it's probably not what we want right now if you want like exact counterpart of this. So I would do pixelate 1, 1, so that all the pixels on the screen is guaranteed to be the same. It's like a single color, so this whole thing, it was actually like a kind of slight gradient, but with the pixelate 1, 1, it becomes just like one single color. So now it's not making this stretchy effect. And let's see how. So it seems like the phase is a little bit different, but I think movement-wise it goes up to here. And does it go up to here? It does. And the only thing is now the phase is a little bit different, and that's also okay to fix it. I mean, now I think I would say like almost like identical, but if you're like super picky, the phase seems to be a little bit different. And the phase, when I say phase, it's like the starting point of a sine wave, so it's not really the frequency of a sine wave, but like shifted a little bit. And there is exactly this like phase, or like actually called sync parameter on OSC function, which is the third parameter of this. And I'm gonna do like, I don't know, minus math.pi divided by 4 or something. Let's see if, no, they're not the same. And I think this is something that I need to like tweak. If it looks like almost the same, but not exactly. It may be that it's just like small thing that how I tune these like OSC 1, these parameters, maybe that's affecting. It's okay, this looks almost the same. There's a little bit of difference, but let's say like it's like good enough effort. Actually, I don't know what value it is. Yeah, like sometimes I just eye it and say like if this is good enough, then it's okay. So this is great. By the way, this trick worked because we're just like working with the red channel. The green channel is actually not affected by this. So whatever, no matter what you do, so it's easy to actually make the counterpart of scroll Y. So if I change from scroll X to scroll Y, the movement becomes horizontal to vertical. But basically the frequency, or how to say, the cycle of it is the same. And the way I changed it is to flip color from 0 to 1, which was for horizontal movement, 0, 1, because now we're keeping green channel, which corresponds to Y, shifting in modulate. So this would do the same thing. Now it's flipped, but the phase is not affected by this. This is kind of a different thing from last example with horizontal, because this sync parameter only changes the phase, shifts the phase of red and blue channel, and that's how it makes this rainbowy effect on the OSC when you say 1, 1 or 30, 0.1, 1.6, then it makes really different colors that it exhibits. But green channel stays the same. So what we could do is to do R, for example, that keeps the red channel, copy the red channel to green and blue channel. It's a little detail, but let's say this is good enough effort to make the counterpart of this with modulate. And why am I doing this kind of cryptic thing with modulate is because if I take this pixelate out, so I'll just take this out, and what happens is now you start to see this interesting, slightly diagonal shift. It was the same with this one that we saw, and this was actually more interesting. So maybe let's stick to this one, which is this stretchy effect. And if you start to increase the frequency of OSC, you see this kind of more rubber kind of texture to it, which is never possible with this notation. You can speed up the time by multiplying by 2, for example, and they essentially do the same kind of movement, but with the modulate it makes this stretchy effect, but with the scroll it's just going back and forth with no deformation of the triangle. And again, this doesn't have to be a triangle. You can use any shape, I would say. Also, one interesting difference here is that if you take noise, we could do something very similar, maybe noise 3, but then what you notice with scroll X is that there is this kind of edge that is not continuous. If this is the effect that you want, visual effect that you want, that's great. But in this particular case, it doesn't really look pretty. And it's different in the case of modulate, because modulate doesn't wrap things around. Well, let's take this stretchy effect out. And you can see that it's coherent, how to say? Yeah, it's continuous. And there is no edge. And it's also giving very similar visual effect or movement as scroll X. And if you actually want this kind of edge thingy with modulate, then what you can do is to add repeat. Oh, I can't spell repeat. 1 1, which is why would someone do repeat 1 1? Because it's basically the same thing that happens, but outside the frame it repeats the pattern, so it basically does something just like this one. Now see it's almost the same effect that's happening. So there are little details, and what could be interesting is if you take this pixelate out, then you can see this edge kind of effect that comes in with this modulate stretchy effect and this edge effect, if that's something you want. That's also possible to make. So I'll just take this out for now, and let's say, okay, this is great, something we achieved. So maybe I'll just keep this as example to be added to the description down below, and let's continue to the next one, which is going to be, I'm just going to keep this on the side because I want to do something a little bit further. So I just copy the same code. So I have like kind of history of it in a separate tab. Now what I want to do is, I'll just like go back to shape. Actually, this should be shape as well to be the same. Yeah, this was the more interesting effect, I would say. Now I would just like take, well, I can keep this there. And maybe I'll work with this one first. And the idea here I want to do is, what if I have scroll X and scroll Y? And this is something a little bit like math kind of thing that I'm going to do here is, what if I have cosine and sine separately for X and Y? This basically makes this circular movement. Why does it work? Well, I'm not gonna like explain math, but basically like, okay, let's say like scroll X with cosine, scroll Y with sine, then you can have this like circle movement. Also, like if you were into like a lissage shape and so on, you can like change one of the phases here, and then this makes this kind of like infinity shape drawing. So it's quite interesting to like explore this kind of thing as well. That's a bit more like P5.js. If you really want to explore this, Hydra may not be always the best tool, because it's a little bit like, it's like sometimes like really like mind bending if you really want to like combine these effects. So maybe it's easy to like sketch it out with P5.js, open frameworks, whatever tool you like. And then I really like also like just advocating like these different tools, because sometimes like this gives like different insight when you come back to Hydra. Like you do something with P5.js or whatever tool, it can be like Touch Designer or anything, and then you discover something and you want to like bring it back to Hydra. How can you make this with Hydra? It's also like really interesting journey. So I highly recommend that too. But now what I want to do here is that I basically want to do something like this with this, and we actually already explored how to do it, because what I'm going to do is basically the same thing. Just multiply these modulates, and one is for X direction, one is for Y direction. Now, the only thing I need here is that, now this is like just doing this diagonal thing again. Again, it's like stretchy, but because that's the problem coming here is in the example below, I have cosine and sine, but here I'm just using the same OSC. So it's basically using sine and sine. Now, but I already told you how to do like phase shifting. I'll just make something really simple. Like let's say phases are 0 and 0, and the difference between cosine and sine is, if you do math, well, how it's defined, I guess, is that the phase is offset by math.pi divided by 4, I guess? Or is it 2? Maybe it's 2. Let's see. Let's verify if I remember it correctly. Now, one of them is offset by pi divided by 2. One of them is not offset. And what happens is, there you go, it's making this circle movement. If I want to make it precise, I can do pixelate 1,1 to verify that it's actually going in circle. Probably now the phase, I kind of simplified it, so it's a little bit different phase from this one. But basically the movement you observe here is essentially the same. And always you can take this pixelate out. I'll just simplify it by this, or maybe I'll just take this out to keep it simple. And you can start to make this kind of like interesting swirl, stretchy effect on top of it. Now, what if I enhance it a bit? Yeah, now it's getting really Hydra-ish, right? But still, like, you see this pattern of like rotation that I found it's super interesting. So this is like second example of what we can do with modulate and the low frequency oscillator using OSC function, which is OSC, like same as like high frequency oscillator OSC. But it's just like, when you change the frequency parameter, the first parameter, then you can use OSC in like different ways to make texture or as a control signal, so-called, to control something. In the last video it was mask on the layer, this time it's a modulate to simulate something just like scroll X, scroll Y, but something more complicated. Now, again, I'm gonna just like keep this example because I think it's nice. So you can find these links in the description down below. And the last example I wanna make is basically with modulate rotate, and it's already like, we've done something, we've done already a lot of things, so it's quite, it should be quite simple. Now, what I'm gonna do is basically the same thing as just like this. What if, okay, let's go back to sine, it's called sin, sine. And in the rotate function, we go from 0 to pi, no, 2 pi, well, pi times 2 is like full rotation. So what if I do like times 3, then it goes like almost, or maybe like math dot pi. Maybe it's a little bit too fast, so I'll just keep it like times 1. So it kind of like goes like from 1, one makes one full circle. And again, this is like rotate with arrow function, just like in P5.js you would do exactly rotate. And you probably don't need this arrow function inside P5.js, but basically you would do something like this sine millis whatever times pi. It's a little bit different notation wise, but the idea is basically the same. You calculate sine and apply it to rotate. Now in Hydra, I'll do something very simple, similar to what I've done in the previous examples, just like this, but with modulate rotate. And okay, it's making this like wiggle because I think I want math pi to be the value here, and I think this is a little bit going wild because I did OSC 4, and also let's start with the pixelate 1.1 so that I think I need times 2 because now it's doing some offsetting, like it's just like times 0.5 plus 0.5 kind of normalization happening here. Well, the opposite of normalization happening here. So anyways, I did add this math by times 2 as a second parameter of rotate, modulate, rotate, but basically, essentially, this is almost the same as the counterpart below. Yeah. Again, the phase is a little bit different, but you see that it goes all the way to the top and makes one full circle, and it just repeats. And the frequency, the time for this one cycle is the same as the one this example below with arrow function, but with this one I'm just purely using Hydra functions like OSC and so on to recreate what is down here. And again, the interesting part of this example is that you can take this pixelate out to make this kind of funny effect. And also the bonus is that you can combine these different functions that we explored today. For example, this kind of circly movement combined with modulate rotate, that's also possible. So you can go really wild with all these things. And what I find it's like interesting to work with something like this is that you can almost make some kind of like motion graphics, no, how it's called. You can really like create these motion, and it's still like observable that it's doing this rotate and this kind of movement at the same time, but also it adds this Hydra touch to it, or more than a touch, that is like really Hydra in a way that you can really see this kind of like rubber, or how to say, this stretchy effect. And also I didn't explore in this video, but there's nothing, stopping you from adding feedback to it. If you do luma on this shape and combine it with the previous frame and so on, you can really create interesting composition with it. And that becomes like really like the, how to say, the advantage of using Hydra in this particular example. So always like, also like as I said in the video, like in the earlier in this video, that comparing like how would you do it with P5.js, how would you do with Hydra, it's also like giving like interesting like ideas. So that I highly recommend, like learning Hydra is not only the way to master Hydra. If you're not familiar with P5.js, maybe it's interesting to like go through tutorials or other tools. I should also learn other tools and bring things into Hydra. And so this is like the motion chapter of Hydra book. And in the next video, I want to explore a little bit on GLSL, like custom shader, but I'm not going to go too far with it, because then I really have to explain how to write GLSL code. But if you're already familiar with how to use GLSL, that may be helpful to create your custom GLSL shader into Hydra. And if you're watching until this moment, thank you for watching. If you create something interesting, please share in the comment down below. Also, suggestion, question, everything's welcome. And I'll see you in the next video. Bye.